Hello everybody, this is Ashish. Today I'm going to show you how the multi-cloud data pipeline works and how it is possible. So first now we do have the data sources in our Postgres, which is in the AWS RDS, and we do have a destination as a storage and any other services as a Lakehouse, which is set up in our Azure machine, Azure instances. So for example, a scenario when client to have the applications, or we to have an application running in the AWS machine, AWS infrastructure, but those data is needed to Lakehouse, which is currently set up in our Azure. So basically, here I do have a Synapse Analytics as a service, which is working as a Lakehouse and which has the Azure data lake storage ADLS Gen 2 as a storage, and Delta Lake and Spark as a as a storage, the Delta tables, and processing with the Spark, and ultimately that Delta tables can be accessible to BI, data science, and data analysis tools. But this part will be in the next section, later on the upcoming sessions. But for us now, up to this point where any data coming in will be moved to the Azure as soon as the transaction happens. So for example, a new user is added in our RDS Postgres instance. It should be populated as soon as possible to our storage as a Delta, and that can be accessible by the business analyst, data scientist, or data analyst, or any other applications that we want to do analysis on. So this is a high level overview of the architecture itself, but let me show you how the RDS and EC2 are aligned as well. So basically we do have the RDS database. Basically this RDS has this Postgres database running. So this database can hold SQL Server, MySQL, or Postgres database, but for us now I'm using the Postgres. And we do have a EC2 instance as well. This EC2 instance is acting as a host, acting as a self-hosted integration runtime service, because this RDS is actually running in my private subnet, private cloud. I don't want to expose it to the public because it has very crucial information. I don't want to expose. So for this case of scenarios, I have to make this one accessible privately. For that one, integration runtime service, this is a Windows application which is given by the Microsoft. So this will help us to have the private communication channel, private communication between our services, our private network to the Microsoft services, without going that to public and without any incoming request. So it just can have the outgoing request. So it's like acting as a gateway. So I will show you how the gateway looks like. So basically that EC2 instance I have shown you, and over the architecture as well. This EC2 instance machine, which is running in AWS itself. These services are running in AWS. So this integration runtime application is running there in the EC2 machine, which is a Windows based system. This is connected from my system using RDP, remote desktop protocol. So you can see I have downloaded these two applications and set it up there. So the self-hosted integration runtime service, which is connected to the data factory, Synapse data factory. I'll show you how it is connected, and also it has a this computer connected. This is exactly the same instance where the integration runtime hostname. This is a hostname, just to make sure. This is a hostname which is now connected to the Synapse. So for that, that's just a pretty straightforward thing. You just have to create the self-hosted integration runtime like this, and just pass in these keys to that in self-hosted integration runtime. Though this is a temporary services, that's why I'm showing you the key, as it is not that crucial for me now. I'll remove this services as soon as possible. So the next thing is I do have the name, which is the EC2. It's connected to uh, the integration runtime that is running on the Windows machine, which is currently running and connected. So it means now uh, the service that is private in a subnet, that is in a private subnet, and that is not public, with the help of this integration runtime, self-hosted integration runtime, I'm able to access here. So now I'll show you how that integration runtime can be utilized. Self-hosted integration runtime can be utilized to connect to data source. So let me take you to the pipeline. So this pipeline have there's a data set. So basically this data set is a Postgres database I have created. So you can check it here as well. So the link service data sets. So this is a Postgres, which is this one. So it is connected to the integration service, which is a self-hosted integration EC2 runtime, which is running here as I've shown you. And I do have different tables. Currently I'm using the customers table in a public schema. So in this pipeline, it is working as a data set, and I'm trying to grab anything happening on those tables, anything happening on that tables in the source database. So for that, I do have the PG admin, which is connected to the RDS from the machine itself. So there is a communication between this Windows machine, which is running in the EC2 instance, and the RDS. There is a private communication. They are on the same subnet, they are on the same private channel, so they're together, so it means they're connected. So I can show you that this table has nothing at the moment. I will show you, demonstrate how actually any transaction happening here will be reflected to the destination database. So let me try to insert one record. For example, let me add one ID, because this has the table structure is ID as a primary key and name as a column, and I do have other column as well, but my focus of the demonstration will be just the ID and name for now. So I'm keeping it here as one as ID and Salim as a name. So let me insert into that table, customer table, INSCRT. What happened? Okay, sometimes it acts so weird, but okay. So I do have the insertion. Let me check. This is appear in a table now. So this one ID as a Salim is already inserted into the table. So let me see if that will be reflected to the Lakehouse as I shown here in the destination delta table, ultimately here in the storage account, so that data can be accessible for anybody. So for that one, I need to check because the pipeline actually running every 5 minutes. So the last run was 10:18 because I kept it living, up and running. So it's a 10:21 now. It was running in 18. It should be in 10:23. So you can see my time. So it takes around within next 2 minutes the pipeline should run and pick up the data. But just to make sure, if there is something in my destination table as well. So this is my destination delta table in my Lakehouse. That is nothing. Just to make sure, let's go and see over the data as well. So my table, this is delta. Inside the delta, my delta, so it has a several data there, but just as a latest information, that is nothing in the delta log. Just to show you, because this is my table, but there is nothing that is actually pointed, because the earlier data, the file that is showing something, it's because the delta table has the old records which is already deleted, but it's not like it's not updated. The data table is not showing those deleted records, just to make sure. So it has nothing yet, but it's 22, so it takes around 1 minute to kick off the pipeline. So within that time, let me try to show you how the pipeline actually works. So basically in this pipeline, we do have the lookup activity and the condition, and inside that condition we do have other activities as well. So first, we do have lookup activity. This lookup activity has the source data set as a Postgres which is connected, and this lookup we can query the table, the source table. This will actually give me the number of transactions, the CDC, the log transaction happening. So basically the count, so basically there's one transaction we did insert earlier, so that insertion activity is it's shown here. So it means that I'm just showing the count. So if I do have the if else condition here, if the condition is showing from the lookup activity, if the output value which is a change count is greater than 0, then this is true. So if it's true, then I do have all the 3 activities running. So as soon as, like, this is to make sure the data is available there, any changes happen there. So for example, within 5 minutes there is nothing happened and no any transaction happened in my table, there is no any sense to run this copy activity, running processing and all that. So it will just leave it there. So for example, now we do have the copy activity. It is to just to grab all the transaction happening in our source database. If the source table has any transaction happened, then it will give me the list of informations. It is the same query as I was using earlier on the lookup table, but there was a count of transaction, but now I'm just grabbing all the records. So if there, like, it will pull the records and it will try to write it down to the sink. The sink is a JSON file which is written in the Azure data lake storage. So ADLS, I do have this ADLS which is connected here. So it is connected to CDC, so you can check the CDC changes in the CDC new change file. So it has a CDC new change file. You can look at this file as well. I do have the kind of insertion happened in my source table. The table schema was public table, customers was the table name, and column, it has a column name, ID, and temp underscore name, and the final values were one as a ID and Salim as a name, and the last temp underscore name is a null. So it means this is a transaction that has happened. So we're able to first write it down to the ADLS. So it means it will just grab any changes happened and write it down as a file into the ADLS. But now these are all, like, any changes happened, it will be coming like this way. But I want to make sure this changes file should be reflected in a common place in a Lakehouse. in a delta table. So any business analyst, data scientist can use the data table as a common source, and as a they can see all the transactions appeared. So it means if the insertion happened at the source, the insertion happened should be the destination as well. If deletion happened, if any record is deleted in the source, the destination should be deleted as well. So for that action, the notebook is acting. So we do have the notebook, which is delta notebook. It has the as I've shown you, this cdc new changes file has the latest changes coming in. I'll pull the records, I'll pull the data and parse that JSON informations I have seen there, and in a structure format, and that structured data will be then need to be written to the delta table. So in a Python, so we do have like easy accessible way of using the delta tables. So basically ultimately I have to write it down to this delta. I have to merge that record, because anything happening like insertion happen, I need to insert. Any updates happen, need to be updated, and delete happen in the source, delete need to be there. So this is a pretty straightforward query. So any new records coming in have the same ID as the existing ID, because the same ID in the existing ID, same ID is available in the delta table, then it will update. If it's a kind is written as a update, if the kind is written as a insert. So this kind information is coming from the source. So along with the changes information, it will give me the action happened at the source. So for example, the source is deleted, source record is deleted, then it will give me the, hey, this ID is deleted, now need to be deleted. So this merge function will act as a the merge operation. And finally we will have as a delta table, we can see the transaction happened should be populated here. See, the in delta table we inserted one ID and Salim, and insert was the operation, Salim was the name. So it is populated here. So let me try to do other operations as well. So let me try to insert. So let me try to insert another ID as well. Let me add 10, which is says, or add on, and so let me try to update. So let me try to pass few transactions. One transaction is to insert, another is to update the existing record to something different value, to for example Salim to John. Hey, I want to update the existing record, then I'm updating with the John. And I'm trying to, for deletion I have nothing at the moment, but let me try to let me remove the delete for now. I'll show you next. So I will add 10, let me add a few others as well. So insert 11 as John. So I have a 2 insertion, 1 updates. Okay, so let me comment it there and try to see dot transaction at source. So it means 10 is added, 10 is inserted, and earlier, because earlier I did have just to ID 1 and zone name. No, one in zone name. No, something different name, but I have updated that one with the zone. So you can see here, if ID is 1, then the ID is updated with the zone. So 10 is inserted, also another insert which is a zone, because I have inserted another as well, so which is a zone. So it means I do have these changes. So this should be exactly reflected to the source, so the destination. The transaction happens, the updates happen, any deletes happens, at source should be reflected as a summarized view, as a merged view. So let me see when is the next pipeline trigger. So it was 10:28, so it's 32. It should be within 1 minute. Within 1 minute, another trigger will be there. So I have kept 5 minute time interval just to make sure that we will have changes happening will be captured by the next available run. So here let's wait a minute, then we can see the destination will have those transactions appeared. 32, let's go there in a pipeline, how the pipelines looks like. Okay, so and finally, as I mentioned, okay, so basically I was here. So once the notebook process the data and merge it, if the record is already existing, then if something updates has to be there, the update will be done by the help of the Spark and the Delta IO uh, module. And finally, once I have this data, finally there is a function to remove the existing changes. So all the changes will be, if I do the get changes, then the subscriber actually remove the transaction happened, the list of transaction happened. So if I query next time, the existing transaction will be removed, the existing transaction will be removed, and every time I run the pipeline, it will just pick up the fresh changes and count the changes. If the count is greater than 1, it means there is something changed in the source table. Then run the copy activity and run the notebook to merge the data and finally remove that again. So this cycle happens every 5 minutes. So let me see, the pipeline is actually running now because it is a time to run. Okay, so 28, 33, 5 minutes time, every 5 minutes consecutive time, like it is running the pipeline. So it's running. So it takes around 2 minutes to run. So within 2 minutes we should be able to see the changes. Okay, it's finished. So it's so fast now, it didn't even took 2 minutes, just within 13 seconds. So let me take a look at the destination delta. Okay, so the insertion 10 was inserted as I have shown earlier, another 11 was also inserted, and 1 was updated. So it means if we check Adam 10, John 11 and 1, it should be the same record. Adam 10 and 11 and 1 for the John IDs. So exactly source is reflected. Whatever transaction you do, for example, let me do another transaction to delete where ID equals to 11. Let me try to delete the 11th record, so 11 ID, and try to update the 10th ID. 10th ID has Adam name now, but let me take something different name, interesting name. This should be populated here in place of Adam. What happened? Oh, maybe because of this one. Okay, So now, because the 10 id 11 was deleted, and I do have 1 in 10 only, but for the 10 I have updated that to 10. So this should be the final table appeared in our delta table. So in our delta table we do have, so let's see when our next pipeline run, because we need to have the 5 minutes waiting time. So it was in 33, so we need to wait up to 8:38. So it means it will be on the within 1 minute the next pipeline will start running. So let's wait that for that pipeline to run. Meantime, we can have a look at the pipeline again. Okay, just to be clear, this activity will be running every 5 minutes, and the merge notebook is nothing, loading the changes in a JSON file from ADLS and structuring it and writing it to Delta Lake, merging it to Delta Lake. The transactions happened. The transaction is reflected here using merging. This is a very much good advantages of the Delta Lake. So it is 38, so it should be now running again. Another pipeline trigger is started, so it might take a while. Okay, so let it be running. During that time I will show you a few other things. I do have the Spark pools. The Spark pool is this one, which is connected, which is used by our notebook and the job itself. And the link service, I have created the link service for storage account and also for the Postgres, and the storage account to write the data into and Postgres to read the data. So I do have the self-hosted integration runtime as I've shown earlier, so you can see the integration hosted runtime, which is running, is a version which is running, which is easy to machine and all that. That's fine. And also I do have Spark applications. You can see this is a current running application, so you can check the even Spark UI as well. So Spark UI will show me how the job is actually working on and which job is taking what time, and how is the processing performance and all that we can see over there. But let me check if the pipeline is finished, just to make sure. In the pipeline runs in the triggered section, because every 5 minutes, okay, it is succeeded now within 2 minutes. So let me take a look at the notebook. So in the notebook, in data validation section, I do have this table name which is connected. So and okay, so interesting name for the id 10 and one for the zone, one for the zone, one id zone, and 10 interesting name, because the same thing is reflected there. So it means any applications, any user interaction or anything happening in the source table, it's reflected to the our Lakehouse. So it means our business analysts, our data analysts, data engineers, any kind of data applications in our Lakehouse is fresh and up to date. So this is all the demonstration. So in the next sections later I will be coming with other interesting materials. If you have anything, please feel free to comment down. Thank you.